This is Physics Week 9 CA. The force that accelerates a rocket into outer space due to the ejection of exhaust gas at very high speeds, in which direction of the ejection takes place compared to the direction of the rocket's motion. So we know that here they want the direction. In which direction does the ejection take place compared to the rocket's motion? So we have the rocket, point A, and it moves this way, and the exhaust gases move that way. So as the gases move out of the rocket to the negative sense, the rocket itself moves into the positive sense, so it's in the opposite direction. The mass of a bullet is 0.009 kilograms and its speed is 380 meters per second. Here they want the linear momentum, so P equals mv. M in kilograms is 0.09 times 380. You can put it in your calculator. 0.009 times 380. You get 3.42. Now in this question they also accept 3.4 or 3.42. Depends on whether you put the exact same answer or round it to the least significant figures. Here they gave us this table with the force and extension, and they want the spring constant K. We know Hooke's law is F equals delta LK. Delta L being the extension, and in meters, of course, meters, and F the force in newtons. Here we have this point when the force is 2 newtons and the extension is 0.04 meters. And we want K equals F over M. If you don't remember the equation, they gave you the unit here, newtons per meter, so you can just divide the newtons over the meters. Force here is 2 over 0.04. You get K equals 50. And that's the answer, that's your K. The mass of the gun is 0.5 kilograms and the mass of the bullet is 0.009 kilograms. The bullet is fired leaving the muzzle at a speed of 300 meters per second. So in an isolated system, the total momentum of the two objects before the collision is always equal to the total momentum of the two objects after collision. This is the law of conservation of momentum. It states that the momentum before and after the collision is always the same. And in part B, they want the speed of the gun. You can say m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. Here the system in the beginning is originally at rest. They didn't give us any speed, they didn't give us any movement, so it's at rest. So any mass times velocity 0 is going to be 0, so this whole side is 0. m1 is 0.5 for the gun, and v1 we want to find it x, plus m2 the bullet 0.009 times v2 300 equals 0. For 0 equals 0.5 x plus 0.09 times 300 is 2.7 minus 2.7 equals 0.5x minus 2.7 divided by 0.5 is minus 5.4 equals x. Here the answer is positive because they said speed. If they said velocity, speed it's only magnitude. Speed is a scalar quantity, so it's only magnitude. Velocity is a vector, so it has direction and speed. The negative here only represents the direction, with the gun going backward after the bullet is fired. So since it's speed, they only want the magnitude, so only the number 5.4. A ball of mass 0.2 kilograms is moving leftwards at 5.0 meters per second, collides with a stationary ball of mass 0.3 kilograms. Upon collision, the balls stick and move together. Whenever you see they stick and move together, you use this equation: m1 v1 plus m2 v2 equals v m1 plus m2. So I have m1 is 0.2 and it's moving with speed of 5, plus m2 0.3 and it is stationary, so speed is 0, equals v. We want to find it, so x, m1 0.2 and m2 0.3. So we have 1 equals x 0.5 and 1 over 0.5 equals x. You can put it in your calculator, or if you know it, just do it in your head. It's 2 equals x. And if it's written part to the least amount of significant figures, 2, so 2.0 meters per second because they asked for speed. Here they want impulse. We know that impulse J equals F delta T. So J here is, the force is 500 times delta T is 0.160 seconds. So J equals, you can put it in your calculator, 0.16. You get J equals 80 newtons times second. A ball of mass 200 grams collides with the ground with a speed of 3 meters per second. Right after it bounces back, its speed is 2.5 meters per second. So to find the momentum, the impulse, for this question you use the equation J equals mass V1 minus V2. Here the ball first is going down, so it's in the negative sense, and then it bounces back up, so it's positive. Mass is 0.2 علشان it's here in grams, so in kilograms you divide by 1000, and V1 is minus 3 minus plus 2.5. So J equals 0.2 minus 3 minus 2.5. J is 0.2 times minus 5.5. J is 1.1. Here they only want the magnitude, so you don't have to put the negative. You can just cancel it and put the number علشان they only want magnitude. For this question there are two ways to do it. Either use Hooke's law or cross multiplication. A spring of length 15 centimeters is hanged from a ceiling. An 80-gram mass is attached to the free end of the spring and extends by 0.4 centimeter. To produce an extension of 1 centimeter, x grams should be attached to the free end of the spring. So if 80 grams produces a 0.4 extension, so how many grams, x grams, will produce a 1 centimeter extension? You cross multiply 0.4 x equals 80 and x equals 80 over 0.4. Now, for this question, if it ever comes written in finals or periodic or whatever, don't do this way. This is for you to save time in the AMS. But if it comes in the periodic, you have to use Hooke's law. So the answer is 200 grams. When a material goes back to its original shape after a force is removed, the material is said to be elastic. This one you have to memorize it. It's حرفيا the definition of an elastic material. So you have to know it or memorize it. For this question, they want us to match each of the points on the graph with the phase of it. For point A here, it's a straight line passing through the origin. So it is proportional. And the law that we know is proportional is Hooke's law. So Hooke's law is the straight line passing through the origin, point A. Hooke's law is a weight. And then point B is its elastic limit. The elastic limit is right before it starts to bend, the line. So right before the line starts to bend, it is the elastic limit. Point C, this line, the one that's bent, it's plastic behavior. By the way, you have to memorize this question. So this, when the line is bending, it's plastic behavior. And then this one, it's permanent extension. No matter what you do, you can't bring it back to the origin point or point A. It's stuck on point D. As long as the elastic limit of a spring is not reached, this expression F equals K delta L is known as Hooke's law. You should have memorized this by now. F equals K delta L is Hooke's law, always. It can be applied when a force of 50 N is applied on the spring and the elastic limit is elongates by 25 centimeters. For this spring, the spring is constant, K is. So here they gave us the extension in centimeters, we want it in meters, so we divide by 100. So 0.25 equals delta L. And they gave us the law already, F equals K delta L. F is K is F over delta L. F is 50 and delta L is 0.25. You put it in your calculator, you get 200 newtons per meter. The momentum of a body is the product of the body's mass and its velocity. So for this question, they're just saying the equation for momentum. We know P is mv, so the body's mass by its velocity. For this question, you just have to memorize the units for linear momentum, and there is also another question that you have to memorize the units for impulse. An object is falling from a high building. What is the direction of the momentum during its fall? If it's falling from a high building, it's going downwards, so أكيد يعني it's the direction is down. It's just common sense. If you don't know this, you might be cooked. Best. Okay. Also, this one is the law of linear momentum. When two or more objects interact and no external resultant forces acting on them, their total momentum remains constant. Again, this is حرفيا just the law of linear momentum, the law of conservation of momentum. The momentum of two objects before and after the collision is the same except if no external force acts upon them. The diagram below shows a man of mass 90 kilograms and his son of mass 60 kilograms standing still on a frictionless frozen lake. The man pushes his son to the right, so the son moves with a velocity of v equal 3 meters per second. So he pushes him to the right, and the velocity is positive, so the right is our positive sense. We have v1 m1 plus v2 m2 equals v1 prime m1 plus v2 prime m2. V1, they're both standing on a frictionless frozen lake, so they're at rest. They're both at rest, so this full side is 0. We'll count M1 as the man. So M1 is 90. V1 we wanted V1 prime is x علشان we want to find it. V2 of the sun is 3 meters per second and his mass is 60. So 0 equals 90x plus 180. So minus 180 equals 90x. And you divide both sides by 90. Minus 2 equals x. Here they said velocity, so they want a vector force. Direction add magnitude, so it's minus 2. Again, the minus refers to the direction of the force, of the velocity. Since it's minus, the man is going to the left. These units are for impulse. They're the same as momentum, so you just have to memorize kilograms times meters per second and newtons times second. Here they want the impulse momentum principle. We know that delta P equal to J is impulse, and it's equal to F times delta T. That's it. An object of mass m is moving with a constant velocity v along a straight horizontal road. The object is exposed to a constant force F opposing its direction. So the force is negative. So since the force here is 100, it's minus 100 for 5 seconds. They want the change in the object's momentum. So again, delta P equals J, which is the impulse, equals F times T. F here is minus 100 علشان it's in the opposing direction, times T is 5. So delta P equals minus 500, and the unit for impulse or momentum N times second. This question, when two objects collide and exert on each other equal and opposite forces, so basically action and reaction, the law of conservation of momentum gives us evidence that we need to arrive to Newton's third law. Equal and opposite forces, so action and reaction, which is Newton's third law. For each action there is an equal and opposite reaction. So which statements describe what's happening inside a jet engine are true? So imagine this is the jet engine and this is the wing. The air goes through this. The air goes through the propellers, and then there is a compressor here that compresses the air, that compresses it, while fuel is getting ejected into the compressed air, which ignites it, pushing the air backwards and the propeller forwards. So air enters through the front of the engine, compressor blades compress the air, and fuel is injected and burned with the compressed air. The wing doesn't push the air backwards. The wing doesn't push anything. High-speed solids are ejected, not solids. The gas is ejected backwards, so it's wrong. So only the first three are correct. For this question, you can just know keywords. So upward, the upward force lifts it up. The forward force thrusts it and pushes it forward. The forward force. The horizontal force, the only one left is the drag. So the drag is the horizontal component of the reaction of the air on the airplane's wings. The lift is the upward component of the reaction of the air on the airplane's wings. And the thrust is the forward resulting from the air being pushed back by rotating plates. So you need to memorize this. The boat's hull is designed to rise a little in the water and reduce drag. So the water is here for example يعني the water is here and the hull goes up towards up a bit, so it reduces the drag from the water. The boat pushes forward and the water pushes it backwards. That is drag, the reaction force. So the hull is upwards a bit, so it doesn't experience as much drag. So when humans move forward, their feet, imagine this is a feet or whatever, pushes, as you take a step, you push back on the earth. So as a reaction force, the earth pushes forward, so you can walk. When humans move forward, they push the ground backwards with their feet. In which direction does the ground push the feet in return? Again, Newton's third law, equal in magnitude and opposite in direction. So since the force is backwards, the direction is forwards. Two particles, A and B, of respective masses 0.060 grams and 40 grams are moving towards each other with speed of 5 meters per second. Since they're moving towards each other, they're moving in opposite directions, so one of them is negative. We take it here that it's particle B that's moving in the negative sense. So m1 v1 plus m2 v2, and if upon collision they stick together, again whenever you see stick together you use this equation, m1 v1 plus m2 v2 equals the vf m1 plus m2. Here the mass is in grams, we want it in kilograms, so it's 0.06. We divide by 1000 and 0.04. m1 v1 0.06 times 5 plus 0.04 times negative 5 علشان we said that they're moving in opposite directions equals vf, we put it x علشان we want to find it, و m1 0.06 plus m2 0.04. So 0.06 times 5 is 0.3 plus 0.04 times minus 5 is minus 0.2 equals x, and 0.06 plus 0.04 is 0.1. 0.3 minus 0.2 is 0.1 equals 0.1x. 0.1 over 0.1 equals x, and 1 equals x. So on. And since the answer is positive and A was the one that's moving in the positive sense, they move in the direction of A. A cart A of mass 4 kilograms is moving in a straight line at speed 3 meters per second towards a stationary cart B. So cart A is its mass is 4, mass 4, and speed 3. Stationary cart B, they didn't give us speed, stationary, so it's at rest 0, and they didn't give us the mass, so they want the mass. The cart moves in opposite directions, each with speed of 1.0 meters per second. And here they told us that the initial direction of motion of cart A is the positive. So they want the momentum, for part A they want the momentum of cart A before the collision. So P equals mv, m is 4 and v is 3. So P is 12, and the mass of cart B is, we want the mass, m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. عشان هنا they move in opposite directions after the collision. So m1 v1 is m1 v1, we already did it for part A, is 12, plus m2 v2, it's at rest, so the velocity is 0, so the mass cancels command, so it's plus 0, equals m1 v1 prime, m1 being the 4 for cart A, and v1 after the collision is 1, plus m2 v2, m2 is x, and v2 is minus 1. Sorry. So after collision, cart A is moving this way, and cart B is moving this way. So after the collision, cart A moves that way, to the left instead of the right, and cart B moves to the right. So since A in the beginning is the positive sense, cart B after the collision moves in the positive sense, and B in the beginning moved in the negative sense. So A in the beginning, A after the collision is moving in the negative sense. So it's 4 times negative 1 v1 prime, and x for m2 and v2 prime is 1, so just x. So 12 equals minus 4 plus x, and 12 plus 4 equals x, so 16 kilograms equals x. Here is the direct application of Hooke's law. F equals k delta L. The spring at the beginning was 5 centimeters, and then it becomes 15 centimeters, so delta L is 15 minus 5 is 10 centimeters. We want it in meters, we divide by 100, so it's 0.1 meters. F is 20, they gave it to us, and before that k is F over delta L. So F is 20, delta L is 0.1, so k equals 200. A 15 grams bullet is fired from a 5 kilograms rifle with a speed of 500 meters per second. The magnitude of the initial momentum of the system. So in the beginning, they're both at rest. Both of the whole system is at rest. The rifle and the bullet, they're both at rest. So since they're both at rest, the total momentum of the first side, m1 v1 plus m2 v2, equals m1 v1 prime plus m2 v2 prime. Since they're both here at rest, so the total momentum before the collision, before the action, is 0. And then they want the recoil speed of the rifle is x meters per second. So we said in the beginning it's x, and m1 v1 prime, m1 we're gonna put it the rifle, so 15 grams, 5 kilograms, and they want the speed of the rifle, so x plus m2 v2 prime. M2 is the bullet and it's in grams, we divide by 1000 عشان we want it in kilograms, so it's 0.015. we check on the calculator, yeah, 0.015 kilograms. So plus 0.015, and the speed is 500, equals x equals 5x plus 7.5. You move it to the other side. Sorry, this is the first side is 0, not x. So minus 7.5 equals 5x minus 7.5 divided by 5 is minus 1.5 equals x. They want the speed, scalar, so only magnitude, so only the number, and it's 1.5. So for this one, we a 2 kilogram trolley is subjected to a constant horizontal force of magnitude 10 n for 3 seconds. We first find the impulse or the momentum. So delta p equals j equals f t. So f is 10, t is 3, so p is 30. And then we use the other equation for momentum, p equals mv. Here they want the velocity at the end. P is 30, we found it using the other equation. M is 2 kilograms, they gave it to us. 2x. We divide the 30 by 2, so 15 equals x. 15 meters per second. A 1500 kilogram car is moving to the right with a speed of 20 meters per second when it collides with the wall and rebounds with a speed of 5 meters per second. If the collision lasts for 250 milliseconds, then the magnitude of the average force on the car is blank kilonewtons. They want here the answer in kilonewtons, so at the end we're going to divide by 1000. First we find the momentum. P equals m v1 minus v2. Since it's moving to the right with this speed, it's in the positive direction, and then it rebounds, so it moves to the left with a speed of 5, so this is the negative direction. So P equals m 1500. V1 is 20.0 minus 5 for V2. So P equals 1500 times 25. You can put it in your calculator or do it in your head. You get P is 37,500. So this is the momentum. Then we want to find the average force. So they gave us the time. 1 second is equal to 1000 milliseconds. So we divide this by 1000 to get the answer in seconds, so it's 0.25 seconds. And we know the equation, delta P is equal to F times T. So we got P is 37,500 divided by T is F 0.25. You put it in your calculator, you get 150,000 newtons. And since they want the answers in kilonewtons, you divide by 1000, so it's 150 kilonewtons. I mean, this question is common sense, it came in the periodic. A rotating bicycle wheel pushes the earth backward. The wheel pushes the earth backwards, so the earth pushes the wheel forward. The human moving by pushing the ground backwards, the human pushes the ground backwards, so the ground pushes the human forward. The boat propeller pushes the water backwards, so the water pushes the propeller forwards. And a rocket engine, the rocket's gases pushes the ground backwards, downwards. So the ground pushes the rocket upwards. Sorry. The engine pushes the gases downwards, so the gases pushes the engine upwards. And this is all of the physics for week 9 CA.